Hello friends, today we will learn vector and scalar. Friends, when we go to the market for buying sugar or vegetables, we do not say the shopkeeper to give 5 kg sugar in East. We do not say that. We only say that give me 5 kg sugar or 5 kg potatoes. So some of the quantities do not require direction for its describing. So such quantities are called scalar. So scalar a scalar quantity has magnitude only. We do not need direction for this. Consider you have to add 3 kg and 5 kg. That gives 8 kg. So, a scalar quantity can be added by simple algebra. This is the magnitude and this is the unit. Now, some of the quantities requires magnitude and direction also. Then such quantities are called vectors. Now consider this is a block and you are applying 5 Newton of force on this. Now you must specify the direction also, in which direction you are applying the force. So 5 Newton in east direction. Okay friends, so a vector is a quantity that has magnitude, direction, and third, it must obey the triangle law of vector addition. This is much important. For examples, velocity, acceleration, force, momentum, These are vector quantities. etc. Now for scalar quantities, some examples are time, temperature, mass, speed, etc. So a vector quantities must have magnitude, direction, and it must obey the triangle law of vector addition. Now a vector is denoted by an arrow sign. This is called the tail and this is called the head of the vector. You can represent a vector by putting arrow, or you can make it bold Now, what is triangle law of vector addition? Now friends, consider two vectors, vector A and vector B. Now you have to add these two vectors. You cannot add vectors by simple algebra like scalars. So you can add vectors by triangle law and parallelogram law, which we learn after this. So what you have to do, you have to put the second vector. You can take any one vector as first vector and any one vector as second vector. So here we are taking vector A as the first vector and vector B as second vector. So what we have to do, we have to put the second vector tail on the first vector head without changing the direction of second vector, because changing the direction of vector changes the vector. So keep in mind, you cannot change the direction and magnitude of a vector. So put the second vector, that is vector B, on the first vector in this way. This is vector B. So put the second vector tail on the first vector head. Then this vector is called vector A plus vector B, or resultant vector of A and B. Now consider a second example. This is vector A and this is vector B. We have to add by triangle law. So I am taking vector A as the first vector. So what we have to do? This is the first vector. Put the tail of the second vector on the head of first vector without changing the direction of second vector. So this vector is the resultant of A and B. This is A plus B vector. Okay friends. Now friends, consider this figure. In this figure, it is an electrical circuit. 10 ampere current is flowing through this wire, and at this junction it is distributed in 6 ampere and 4 ampere. Here you can see the current has magnitude. This is the magnitude. The current has magnitude and direction also. But since it is not obeying triangle law of vector addition, so current is not a vector quantity. It has magnitude and direction, but it is not obeying triangle law of vector addition. So current is not a vector quantity. It is a scalar quantity. So it is important to keep in mind that a vector must obey triangle law of vector addition. So thank you for watching this video.